У лаборатории несколько научных тем из самых разных областей. Это финансовая математика, математическая биология, микроэлектроника, управление, морская тема и холодная плазма. За время существования лаборатории каждую неделю работает семинар. Есть семинар лаборатории, а есть семинар совместный с семинаром Леонида Берлинда. Оба семинара регулярно работают, но, правда, к сожалению, семинар лаборатории пока дистанционный и никак в очный формат не выйдет.
Простите, вот время существования лаборатории сколько?
3 года.
В настоящий момент?
Ну да, примерно. Участники лаборатории выступают на конференциях. Например, Оля Розанова делала доклад в Сириусе по холодной плазме, а Виталий Черник делал доклад в Америке, в Силиконовой долине, про микроэлектронику, и его доклад вызвал большой интерес. Защищены 2 диссертации. Одна докторская, это Владлена Шумилова, ученица Алексея Станиславовича, и Сергей Дрожжин, ученик Александра Сергеевича Братуся. И представлены к защите еще 2 диссертации. Докторская – это Игорь Романов, и кандидатская – это Виталий Черник. Оба ученики Алексея Станиславовича, и защиты обе планируются в ближайшее время. Опубликовано 13 статей из Q1 по темам лаборатории, 6 статей из Q2 и 48 из Scopus. У лаборатории есть сайт, вот этот, на него есть ссылка с сайта нашей кафедры. Ну, собственно, это все, что я хотела рассказать. Еще есть фильм по микроэлектронике. Этот фильм снят в швейцарской лаборатории, и там прямо вот оборудование, которое создано по идеям, которые придумали сотрудники лаборатории в микроэлектронике. Если фильм запустится, можно будет его посмотреть. Все, спасибо за внимание.
SWHL is sub-wavelength holographic lithography, which is a revolutionary lithography technology that significantly, up to 10 times, decreases the cost of lithography process, produces three-dimensional topologies at one exposure, and operates across all technological nodes. Here you see the main principles of holographic lithography in comparison with traditional lithography. In traditional lithography, you need a light source, complicated illumination optics, projection lens, which is even more complicated system that can consist of up to 40 optical elements, projection mask that has extremely complicated structure, especially for high resolutions. Light goes through the system and produces two-dimensional images on photoresist. In holographic lithography, you need a source of coherent light, you need simple illumination optics, you do not need projection lens. Instead, you use holographic mask that has a very simple, regular structure and acts not only as a mask, but also as a projection lens. Light goes through the system, and after diffraction on elements of the holographic mask and interference, produces not only two-dimensional but also three-dimensional structures at one exposure with high resolution. SWHL technology is protected by 7 US patents, know-how, and proprietary software developed by our team. In our laboratory at EMPA in Dubendorf, we have built a holographic demonstration tool to verify the concept of the technology, to prove that holographic steppers have very simple optical system, and to confirm that SWHL produces three-dimensional images with one mask at one exposure. We use a heli-cadmium laser with wavelength 442 nanometers and power of 100 milliwatts. Illumination optics includes off-axis mirror beam expander, it also includes a 3-lens condenser that forms convergent spherical wave. This wave goes through a holographic mask, in this case 44 millimeters in diameter, and after diffraction and interference, create an image in the focal plane of the condenser. Wafer stage is precisely aligned to the focal plane of the condenser. In the absence of a wafer, the image can be registered by the image registration camera, as we currently do. Now we will show you how the light travels in the demonstrator to produce an image. Light from helium-cadmium laser goes through a shutter and an attenuator. After that, 2 mirrors directed to a preliminary expander to adjust the beam energy cross-section. The light wavefront is then adjusted by the wavefront corrector, and with the help of off-axis parabolic mirror is turned into a horizontal collimated beam 70 mm in diameter. The folding mirror turns the beam to the condenser that forms a convergent spherical wave. The convergent wave goes through a holographic mask, and after diffracting on mask elements, an image in the focal plane of a condenser is formed. We use a special diaphragm to block the unused light from orders of diffraction. We place diffraction orders at significant distance from each other so that they can be blocked by the diagram and do not damage the quality of the useful aerial image. The wafer stage precisely aligns the lower surface of the wafer with the focal plane, and an image is created on the wafer. Currently, for this video, no wafer stage is used. Aerial image is observed and controlled with the help of the image registration camera. As we have mentioned, the goal was not only to demonstrate that holographic lithography can create images using very simple optical design, but also show that it can produce three-dimensional images at one exposure. We have synthesized holographic masks and had them produced by IMS chips. One of these masks is now installed in the demonstrator. It creates images with resolution of 2 microns on 2 planes located at a vertical distance of 100 microns from each other. And it does it with one exposure, as shown on this picture. Now we show you the demonstrator in operation. We use the image registration camera to capture the image. Now the camera shows the image on the bottom plane. The image is sharp. We move the camera horizontally to where the image on the top plane is located and lift it vertically by 100 microns. We see a sharp image on the top plane. The camera has depth of field less than 6 microns. That's why we cannot show images on both planes simultaneously. But holographic mask produces such three-dimensional images in one exposure. So the demonstrator confirms that design of holographic steppers do not require projection lens, and that SWHL produces images on three-dimensional surfaces with resolution not being limited by the depth of topology. On these photos, you can see images on the top plane as made by computer simulation and as produced by the demo tool at different levels of exposure. Width of minimal line is 2 microns. Distance between the planes is 100 microns. So even such a simplified holographic demonstrator produces images that are in good correspondence with computer simulations. We have also produced images in photoresist, and resolution of 2 microns has been confirmed. So to summarize, we have shown to you the demo tool of a holographic stepper. Holographic lithography is an alternative lithography technology, offers significant cost savings, especially at high technology nodes. It provides unique possibility to create 3-dimensional images at one exposure with one mask, with resolution not being limited by the depth of topology profile. Please write to us in case you have any further questions.
Ну, на этом мы завершаем нашу сегодняшнюю конференцию. И я поздравляю всех с наступающим Новым годом. Как видим, у нас много новых интересных результатов. Несмотря ни на что, кафедра живет и работает. Я желаю всем счастья, здоровья и успехов. И приглашаю на кафедру.